we are going to solve the integral equation. First problem, solve the integral equation g of s is equal to s plus lambda integral 0 to 1 st square plus s square t into g of t dt, right? So given equation g of s is equal to f of s plus lambda into integral 0 to 1 st square plus s square t g of t dt. That is equation number 1. So given g of s is equal to s plus lambda integral 0 to 1, then something, right? Integrand. Here we have taken g of s is equal to f of s. So instead of s we are taking f of s. So f of s is a function that is equal to s, right? So where f of s is equal to s. So now we are taking the kernel. Kernel is nothing but in the integrand. So you have to take the function nearby g of t. So here nearby g of t in the integral is t square plus s square t. So kernel k s comma t is equal to s t square plus s square t. This can be written as a1s into b1t, first term. a1s is s and b1t is t square plus second term a2s into b2d t. So a2s is s square and b2t is equal to t, right? So this is separable kernel, right? Now let us take ci. We know that instead of so take let, right? ci which is equal to integral 0 to 1 bi of t g of t dt, right? Now put I is equal to 1, c1 equal to integral 0 to 1 b1t g of t dt. So for our convenience we are taking ci which is equal to integral 0 to 1 bi of t g of t dt, right? So first c1 equal to integral 0 to 1 b1 of t g of t dt, that is equal to integral 0 to 1 b1 we know t square g of t dt. c2 is equal to, so substitute I is equal to 2, so you will get integral 0 to 1 b2t g of t dt, that is equal to integral 0 to 1 b2 of t is t g of t dt, right? So 1 implies, so g of s is equal to f of s plus lambda integral 0 to 1 s t square plus s square t g of t dt, which is equal to s plus lambda integral 0 to 1. We are splitting into 2 the integration, right? First 0 to 1 integral s t square, first term g of t dt plus lambda into integral 0 to 1 s square t g of t dt, second term, that is equal to s plus lambda. You can take s outside because the integrand is with respect to t, right? So we are taking s outside, so s is a constant. So lambda s integral 0 to 1 t square g of t dt plus similarly we are taking s square outside from the second integral, right? Lambda s square integral 0 to 1 t g of t dt. This implies g of s is equal to s plus lambda. So we can substitute the value of that integral values, right? We know c1 equal to integral 0 to 1 t square g of t dt and c2 is equal to integral 0 to 1 t g of t dt. Substituting that one, so s plus lambda c1 s plus lambda c2 s square, right? This is equation number 2. So using 2 in 1 s g of s instead of g of s left hand side, right? So g of s is equal to, so we are substituting from 2 s plus lambda c1 s plus lambda c2 s square, which is equal to, so s plus lambda into integral 0 to 1 s t square plus s square t. So instead of g of t you are substituting the value from equation 2. So g of s is equal to s from 2 g of s is equal to s plus lambda c1 s plus lambda c2 s square. So replace s by t, you will get g of t, right? G of t is equal to t plus lambda c1 t plus lambda c2 t square. You substitute there, right, in the integral, right? So s t square plus s square t into t plus lambda c1 t plus lambda c2 t square dt. So that is equal to, that implies so here s left hand side also you are having s, right hand side also you are having s, both are get cancelled, right? So remaining term lambda c1 s plus lambda c2 s square equal to lambda into, right, integral 0 to 1 s t square plus s square t right, into t plus lambda c1 t plus lambda c2 t square dt. This implies, so in the left hand side lambda is common, take it outside, lambda into c1s plus c2s square, which is equal to lambda into right hand side integral 0 to 1 st square plus s square t into t plus lambda c1 t plus lambda c2 t square dt. So you can cancel lambda on both side, right hand side and left hand side you are having lambda, cancel lambda, so you will get c1s plus c2s square equal to integral 0 to 1 st square dt, right. So we are multiplying and splitting the integral. First term st square into t st cube dt plus integral 0 to 1 s square t into t square, right, dt plus next lambda into integral 0 to 1 c1 s t cube, right, second term st square into lambda c1 t, right, you will get c1 st cube dt plus lambda into integral 0 to 1 st sc2, we are taking the next term s c2, right, st square into lambda c2 t square, so you will get s c2 t power 4 dt plus lambda into integral 0 to 1. Next we are multiplying c1 c1 lambda c1 t into s square t, right, so you will get c1 s square t square dt, then remaining term plus lambda into integral 0 to 1 s square c2 t cube dt. That implies c1s plus c2s square equal to s is constant, take it outside from the all the integral and write it as it is, right, s integral 0 to 1 t cube dt plus s square integral 0 to 1 t square dt plus lambda c1 next term, right, etc etc plus lambda c2 last term s square, all are constant, take it outside, integral 0 to 1 t cube dt, because the integral is with respect to t only, so keeping t term inside and remaining all the terms outside the integral. So that implies c1s plus c2 s square, so integrating, which is equal to s into integral t cube on, that is t power 4 by 4 plus s square, integral t square is t cube by 3, limit is 0 to 1, all are 0 to 1 only, then lambda c1s t cube is t power 4 by 4 plus lambda c2 s into t power 4 integral t power 4 is t power 5 by 5, limit is 0 to 1 plus lambda c1 s square integral t square is t cube by 3, limit is 0 to 1 plus lambda c2 s square last term integral t cube is t power 4 by 4, limit is 0 to 1. Substituting upper and lower limit, c1s plus c2s square, which is equal to s, only upper limit, lower limit is 0, so all term becomes 0 when you are applying the lower limit. So applying the upper limit 1 by 4, right, s into 1 by 4 plus second term s square into 1 by 3 plus lambda c1s 1 by 4 plus lambda c2s 1 by 5 plus lambda c1s square 1 by 3 plus lambda c2s square 1 by 4. So c1s plus c2s square equal to, so 1 by 4 plus lambda c1 by 4 plus lambda c2 by 5 into s, keeping s term outside, so there are 1 2 3 terms with s and remaining term with s square, so keeping s outside, so you will get first term, then keeping s square outside, then you will get the second term 1 by 3 plus lambda c1 by 3 plus lambda c2 by 4 into s square. Comparing the coefficient of s and s square on both sides, right, you are having left hand side c1s plus c2s square, right hand side you are having 1 by 4 plus lambda c1 by 4 plus lambda c2 by 5 into s plus 1 by 3 plus lambda c1 by 3 plus lambda c2 by 4 into s square. Comparing the coefficients on both sides, right, so c1 equal to 1 by 4 plus lambda c1 by 4 plus lambda c2 by 5 and c2 is equal to, so c1 equal to, we are going to simplify c1 minus taking all the terms to the left side, c1 minus lambda c1 by 4 minus lambda c2 by 5 minus 1 by 4 equal to 0. So taking c1 outside from the first two terms, So 1 minus lambda by 4 into C1 minus lambda C2 by 5 minus 1 by 4 equal to 0. That is lambda by 4 minus 1 C1, right, multiplying with minus all the terms, right, plus lambda C2 by 5 plus 1 by 4 equal to 0. That is equation number 3. Now comparing the second one, s square term, right, C2 is equal to 1 by 3 plus lambda C1 by 3 plus lambda C2 by 4. That implies C2 minus lambda C2 by 4 minus lambda C1 by 3 minus 1 by 3 equal to 0. So taking C2 outside, first two terms, right, 1 minus lambda by 4 into C2 minus lambda C1 by 3 minus 1 by 3 equal to 0. So lambda C1 by 3 plus multiplying with minus plus lambda by 4 minus 1 C2 plus 1 by 3 equal to 0. That is fourth equation. Now we are going to find the value of C1, C2 by using the equations 3 and 4. We are going to solve the equation 3 and 4 to get C1 and C2, right. So 3 into lambda by 3. So lambda by 3 into lambda by 4 minus 1 into C1 plus lambda square C2 by 15 plus lambda by 12 equal to 0. 4 into lambda by 4 minus 1. So lambda by 3 into lambda by 4 minus 1 into C1 plus lambda by 4 minus 1 square C2 plus lambda by 4 minus 1 into 1 by 3 equal to 0. Now we are going to subtracting, change the sign, minus minus minus. So first two terms get cancelled, 0, right. Second term lambda square C2 by 15 minus lambda by 4 minus 1 square C2, right, plus last term, right, lambda by 12 minus lambda by 4 minus 1 into 1 by 3 equal to 0. That implies lambda square by 15 minus lambda square by 16 minus 1 plus 2 lambda by 4 into C2. So we are taking grouping C2 terms, right. So using the formula a minus b whole square formula, right. So you will get this term, right, lambda by 4 minus 1 the whole square is lambda square by 16 plus 1 minus 2 lambda by 4 into 1, right. So you are having minus, that is why it is coming like this, right. So first term lambda square by 15 minus lambda square by 16 minus 1 plus 2 into lambda by 4 into C2. Then remaining term lambda by 12 minus lambda by 12 plus 1 by 3 equal to 0. So you will get C2 is equal to minus, keeping C2 left hand side, taking that remaining term to the other side, it will come to the denominator. So minus 1 by 3 divided by lambda square by 15 minus lambda square by 16 minus 1 plus 2 into lambda by 4. That is equal to minus 1 by 3, taking LCM. So 240 is LCM, lambda square minus 240 plus 120 lambda. So you will get right, 240 you will go to numerator, right, minus 240 by 3, right. Then denominator you are having lambda square minus 240 plus 120 lambda, right. So multiplying by minus on both sides. So 240 by 3 80, right. So minus, multiplying by minus numerator and denominator, minus will get cancelled. So 80 by, so multiply the denominator with the minus, so it will reverse, right, 240 minus 120 lambda minus lambda square, that is C2. That is equation number 5. From 3 and 5 substitute the value of C2 in 3. So we will get lambda by 4 minus 1 into C1 plus lambda into 80 by 240 minus 120 lambda minus lambda square by 5 plus 1 by 4 equal to 0. So lambda by 4 minus 1 into C1, taking that remaining term to the right hand side, minus 1 by 4 minus lambda 80 divided by 5 into 240 minus 120 lambda minus lambda square. That is equal to minus 1 by 4 minus 5 and 80 get cancelled. So lambda into 16, 240 minus 120 minus lambda square. So that is equal to lambda by 4 minus 1 into C1 equal to, taking LCM, right, just to do the cross multiplication. So you will get the LCM 4 into 240 minus 120 lambda minus lambda square in the denominator. In the numerator, minus is common, take it outside. So 240 minus 120 lambda minus lambda square, just to do the cross multiplication. Then 4 into 16, 64 lambda. So that implies lambda minus 4, taking LCM on the left hand side, 4 is the LCM. Lambda minus 4 C1 by 4, that is equal to minus 240 minus 120 lambda minus lambda square plus 64 lambda by 4 into 240 minus 120 lambda minus lambda square. Therefore C1, keeping C1 left hand side, taking that remaining term the other side, so it will become the reciprocal. So minus 240 minus 120 lambda minus lambda square plus 64 lambda, right? Then 4 by lambda minus 4. 4 and 4 get cancelled. So remaining you are having in denominator lambda minus 4 into 240 minus 120 lambda minus lambda square. So lambda square, so in the numerator simplifying, right? Lambda square, so minus 120 lambda plus 64 lambda. So you will get plus 56 lambda minus 240 divided by lambda minus 4 into 240 minus 120 lambda minus lambda square. So dividing lambda square plus 56 lambda minus 240 by lambda minus 4. So using divisions, right? Algebraic division, right? So taking lambda square plus 56 lambda minus 240, so divided by lambda minus 4. First term lambda, so multiply lambda into lambda square you will get, right? So lambda square minus 4 into lambda minus 4 lambda. Now subtraction, minus plus. So first term gets 0. So 56 plus 4, 60 lambda. Then remaining term minus 240. Bring down, right? Now you are having lambda minus 4. So you are having 60 lambda. So multiply lambda minus 4 by 60. So you will get 60 lambda. So plus 60. So 60 lambda. Plus 60 into minus 4 minus 240, so subtraction, so change the sign, 0. So you will get C1 equal to, so when you dividing that one, so you will get numerator 60 plus lambda, right, by 240 minus 120 lambda minus lambda square. So 2 implies the solution is G of S is equal to S plus lambda C1 S plus lambda C2 S square. That is substituting the value of C1 and C2, is equal to S plus lambda into 60 plus lambda by 240 minus 120 lambda minus lambda square S plus lambda into 80 by 240 minus 120 lambda minus lambda square S square. So taking the LCM, S into 240 minus 120 lambda minus lambda square plus 60 lambda S plus lambda square S plus 80 lambda S square divided by 240 minus 120 lambda minus lambda square. So that is equal to 240 S minus 120 lambda S minus lambda square S plus 60 lambda S plus lambda square S plus 80 lambda S square divided by 240 minus 120 lambda minus lambda square. Therefore G of S is equal to 240 minus 60 lambda into S, right? So S term. Then remaining you are having 80 plus 80 lambda S square, right? Because S square you are having 80. So remaining minus lambda square S plus lambda square S get cancelled. So denominator is 240 minus 120 minus lambda square. Thanks.